Data is everything. It's so specifically for me, it's launchers data. It's about, it's science. It's basically, I do testing. I test engines. We get the data. We work out, does it work as we thought? How can we improve it again? So that's kind of, basic scientific method. But there is a whole paradigm shift going on at the moment, and it's called data-intensive approach to science. There is so much data being created by space missions, by European Space Agency missions, and it creates whole new opportunities, but also creates whole new problems to solve. So we are creating huge amounts of data in Earth observation. European Space Agency, European Union programs on Earth observation are really world-class, some of the best in the world. We have huge amounts of data now on the climate, and now it's a question of how do we best use that data.
Welcome to FLAT Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Haydock. While space might seem a world away from our everyday experiences with the Internet of Things, artificial intelligence and data, our guest today bridges that gap. I'm super excited to introduce Kate Underhill, a rocket scientist from the European Space Agency, ESA. Kate works with the Future Launchers Preparatory Programme at ESA, blending cutting-edge technology with space exploration, from implementing AI in non-destructive hardware inspections to creating intelligent propulsion systems. And we'll also explore if the answer to our global challenges might be written in the stars. Welcome to the show, Kate. I'm really happy to have you. How are you?
Hi, thank you so much for having me. I'm really happy to be here. And I'm enjoying a sunny day in England for once.
Well, congratulations. I heard those are rare these days.
Yes.
So why don't you kick us off by introducing yourself and what you do at ESA?
Yes, well, you've said it exactly. I work for the European Space Agency. I'm actually based in Paris. I'm back home in England on a holiday at the moment where I'm from. I work, as you said, for the Future Launchers Preparatory Programme. I'm technically an upper stage propulsion and demonstrators project manager. It basically means, like you said, I take interesting new technologies and we try and work out if they can be applied to the launches of tomorrow, future launches. And that means looking for things that make our launches cheaper, make them lighter, or make them more versatile, meaning we can do new missions, different missions, going further, going to the moon, going to Mars, going elsewhere.
Very exciting. And what are you working on at the moment?
I've got a lot of projects at the moment, actually. There's a lot going on. I said upper stages, we're looking into new materials. So, for example, at the moment, we use a lot of metallic tanks, and we're looking into carbon fiber, reinforced plastic, CFRP. If that can really give us an interesting aspect between structural thermal impacts, and we can really kind of optimize our upper stage for that. And it has a really interesting spin out towards everyone's talking about hydrogen planes and things like this. Mm-hmm. What we're doing now could really be applicable for everything kind of hydrogen transport and storage in the future.
Okay, cool. So, but just tell me, for my layman brain, when you say upper stage, you mean a part of the rocket?
Yes,
okay.
Sorry, of course. Generally, rockets have stages, 2 or 3 stages. Okay. It's to do with Tchaikovsky's rocket equation. It's to do with the fact that it's not that easy to get into space. And so we actually split up the work by stages. So there'll be a first stage of the rocket will take us off the ground, is going to be big and heavy. It'll fly for a little bit. And then when we've used up all the propellant or the fuel in that stage, well, then we'll drop it. And the point is we try and be as light as possible. So as soon as we don't need something anymore, part of the structure, we let go of that structure go. And that's a stage that's been removed, and then the next stage that will ignite. So often we'll have one stage taking off, and then what we call the upper stage is the one that gets us kind of into space.
Oh, cool. And then you still have, of course, something that needs to keep you moving. So that's the propulsion part of your job description, right?
Yes. So I'm a kind of propulsion engineer originally. So I definitely think propulsion is the most important part of the rocket. And it's what gets you off the ground, and it's what really gets you. And as you're talking about intelligent engines, it's really something we're looking for, something that really can get us to really precise orbital points in the end. Obviously, in space, it's quite big. We want to deliver our satellites, our payloads into really precise orbits. And this is where we can really start thinking about having intelligent engines that are maneuvering very, very precisely to get to these kind of final points. And that means that our payloads are then working straight away in the right place.
And when you say intelligent engines, I think we are already deep into the topic why you are guest on our show today. What is an intelligent engine?
I don't know yet.
Oh, okay. Cool.
It's something we're trying to work on. Exactly. We have, without being too flippant, the laws of physics haven't changed since we started launching rockets. So the engines themselves, the actual how it works, the thermodynamics remain the same. What we're trying to optimize now is procedures, processes, 3D printing. We can do a lot of kind of intelligent elements about optimizing our design for 3D printed parts. But then there's the actual engine itself. And before we've been things with quite something that works, but it's quite old school. Space isn't always that new technology. If something works, we keep using it. But now we're thinking with engines, because of all this miniaturization, electrification, using electric valves, having an engine that thinks for itself. So the computer or the rocket will say, I need to go to this position. And the engine goes, okay, I know that I need to have this much fuel in this position. And the engine decides itself how to operate to get to the final kind of the end point.
Wow. Okay. Exciting and scary at the same time. So are you using artificial intelligence then and to make this machine intelligent, or what technology are you using?
At the moment, so not on the engines. What we're looking more into is just kind of electrification and some control algorithms that are deciding for itself. There is an element I think could be, again, it's something we're working on. We're trying to identify the most interesting applications. Could be something we do engine checkout. We do testing of engines before we fly. Some do testing to test the technology. Sometimes you do testing of an engine before we fly to make sure it works. Could the test benches be intelligent? Can we be a bit more hands-off and let the test benches work out how to test the engines by themselves? We're also thinking things about reusability. That's a big one at the moment. European launchers, they're not reusable. We're working on that for the future. How do we check and revalidate an engine once it's come back from flying? And again, could we have something that's an artificial intelligence machine that's kind of, okay, I'm going to take the engine, I'm going to do the checkout, and I know exactly what needs to be fixed or what's working correctly.
Okay.
This is all the future. This is why I said I don't know exactly what it looks like yet. We're trying to find out the best way to apply all these new interesting kind of technologies and processes to our work. And that's just for launchers. There's a whole other thing going on, kind of space within space itself, artificial intelligence for satellite constellations. If you've got thousands of satellites orbiting the Earth, could you maybe use artificial intelligence to operate them to make sure they're working well together? All these aspects are still under investigation.
Yeah, I did have a conversation before with someone working in the field of satellite IoT, and I learned how many thousands of satellites are basically circling the not even in space, but very close to Earth right now in the low Earth orbit.
I mean, space is big, but exactly, we have orbits that are very much preferred. So low, like I said, low Earth orbit that's where if you want to have worldwide internet coverage. So if you link it to Internet of Things, if you want really successful Internet of Things, you need a global, reliable internet coverage, and you're going to get that from satellites. There is going to be remote areas where it's only going to be satellites that are going to be able to give you the internet coverage you need. But in order to have the internet coverage, you need a large constellation of satellites, thousands of satellites in low Earth orbit. So there are a lot of satellites up there. Getting to work optimally is important. And then also we talk about, avoiding satellite collisions. And that's where something really, really could get artificial intelligence working, identifying other satellites, but also there's a bit of, there's debris in space. There's old bits of rockets that haven't come down yet. There's old satellites that haven't come down yet. We're working on the future. All of our projects now are working towards removing anything we send up, we bring back. But it's been, 50 years we've been working in space. So trying to use artificial intelligence to make this constellations work better and then provide, global internet coverage.
I think you have mentioned something where you use artificial intelligence for non-destructive inspections. Can you explain what that means and what you do?
So exactly, this is linked to what I was talking about, this CFRP, the carbon fiber reinforced plastic upper stage, and where we're trying to assemble in one physical element, one structure. We have the structural element and we have the thermal element. We're using cryogenic propellants, hydrogen, oxygen, which are very cold. So hydrogen is at 20 Kelvin, it's minus 270 degrees Celsius. We need a very good thermal insulation. So our idea is to have this kind of create layers of carbon fiber. There's a carbon fiber tank that holds the propellant itself, but then we have a evacuated sandwich, a vacuum to provide us with the thermal insulation. And it's the elements of making this carbon fiber tank and then sticking the carbon fiber sandwich and then adding extra structural layers on the outside. And all of these elements can be work intensive. And then we need to check each time we add in an element, we have to check that's been assembled correctly, bonded correctly. And we're talking about the structural element. It's a honeycomb CFRP. It's quite a complex structure. Checking every single point is bonded correctly. At the moment we do that, there's some guy that stands there and spends days looking at each bonded element, making sure it's okay. If you can get a machine to do that automatically, then we save time and hopefully also improve the performance. We get better results. We really identify correct points or not.
And I suppose you could also save material in the end, right? If you don't have to basically test it and it explodes and you have to start again. Is that an over exaggeration, or is that what will happen?
There's a real quality issue as well. So if we can, it helps us ensure that our manufacturing process is correct, that we know how to do it, and then that we also can be sure that each part we create is good quality, and then exactly we're not wasting parts from having to throw things away where we're not sure that we've done it correctly, or in the worst case we've accepted something finally that was not okay because we didn't see the problem.
Wow. And you are also working on something called intelligent propulsion. We just touched this with the machines as well.
There's elements where I've talked about intelligent propulsion, maybe for kind of a larger upper stage for an engine, for a rocket engine, but also we think about intelligent propulsion for satellites. There's something we're seeing in the future is something we call about space logistics, where it's not only just getting into space, it's really using space as an economy, moving things around in space, potentially refueling satellites in space, potentially manufacturing elements in space. And that needs a whole different set of transportation options in space. So maybe a launcher will take you up into a certain low Earth orbit, and then we'll have other spacecraft that move you around to your final orbit, or maybe provide you with propellant. And then we're talking about in-orbit rendezvous, docking, and then we really need something intelligent, two intelligent elements, because when you're in orbit, you're going at 10 kilometers a second. So you have two elements together. It looks kind of slow. It looks very calm when you see the space station, but it's going very, very fast. So managing that, getting the safe docking, moving craft around, taking a satellite, moving it to another orbit, we need something kind of very precise in intelligent propulsion systems. And that's something we can start thinking maybe about intelligent propulsion systems, and need something that's quite autonomous. So again, there's a lot of satellite control. There's a lot coming from the ground at the moment. How much could we make autonomous? So again, that we can save time and money and use our people on other elements.
And during our briefing, you mentioned something called cyber physical systems. Yeah. In my mind, it sounds like you're beaming me up somewhere. What are cyber physical systems?
It's this idea again that up until now our systems have been very physical. Structural elements, engines, we build it. And the future is the design. It's a program. It's a software that has physical parts. So it's the software that is the center of the design, and that we can, for example, we have a satellite, and you use software. You upload software that changes the use of that satellite. Satellite itself is multifunctional. It's a Swiss Army knife satellite, and it's the software that we send up that then changes that use.
Oh wow! Okay. And what role does data play in your work? Or in space?
Data. I mean, data is everything.
Big thing. Yeah, sorry.
Yeah. It's so specifically for me, it's launchers data. It's about. I mean, it's science. It's basically I do testing. I test engines. We get the data. We work out does it work as we thought? How can we improve it again? So that's kind of basic scientific method. But there is a whole paradigm shift going on at the moment, and it's what we call data intensive approach to science. There is so much data being created by space missions, by European Space Agency missions, and it creates whole new opportunities, but also creates whole new problems to solve. So we are creating huge amounts of data in Earth observation. European Space Agency, European Union programs on Earth observation are really world-class, some of the best in the world. We have huge amounts of data now on the climate, and now it's a question of how do we best use that data? How do we manage that data, first of all? How do we store it? How do we share it with people? And how do those people then maybe use it to create new applications, new ideas, better models to improve everyday life, but also to improve, our understanding of climate change and how to maybe mitigate it. We also have the same thing linked to lots of science missions. So ESA, the kind of founding ideas of ESA were independent access to space, so launchers, and also science. So science missions is one of the backbones of the European Space Agency. Again, we have world-class, world-beating science missions creating huge amounts of data. I have an idea of Gaia mission, which was launched 2012, 2013, that mapped the Milky Way, mapped the stars in the Milky Way. So it's not necessarily creating new science, but just giving us very precise data about all the stars, or almost a lot of the stars in our Milky Way. That mission has created vast amounts of data that has produced huge amounts of scientific papers that have been published. And again, it's a question of how do we manage that data and how do we work with it in the best way? And it's not just one researcher in a corner anymore going through the data. It's creating a huge database, having people work together on that database. The data no longer goes to the final user. The user has to come to us, and we have to create an environment where they all can work together. It's a collaborative approach, number crunching approach, using artificial intelligence to help us go through the data to identify the interesting points.
So it's quite interesting because I suppose some people wonder, why do we launch rockets to space, or why do we venture into the unknown universe when there are so many challenges we are facing here on Earth? But that's exactly the point, right? That you are learning so much by looking up from above, or having a different perspective. Now seeing all these things and how they come together, and maybe finding a solution for climate change or.
Yep, space is absolutely part of the solution for climate change, for mitigating and for managing and for living with climate change. It's something like 50 out of 54 of the UN climate change markers come from data from space. We have a huge amount. I can also invite anybody who's interested to go and look on ESA Earth observation. Then we have a climate data dashboard where you can see all the current data of sea level rise, temperatures, everything. All this information is necessary for us, all the scientists, to be able to, better understand the current climate. Another example I can give is the Aeolus mission that's just recently, you may have heard about it, recently did a re-entry after a number of years working in space. That was the first ever satellite measuring wind from space. And it's one of those things I hadn't thought about before, but wind measurements until then were just very localized because everybody sent a weather balloon up or something. But this is the first time we actually got global coverage, repetitive coverage of wind. And that obviously helps us really better understand the climate models, better understand the climate as it is, and then be able to better make predictions. And this is something now we're working towards, is using all this climate data to create what we call an Earth's digital twin. So really create a model of the Earth that then, again, helps us better understand the climate. What is it doing now? What's it going to do in the future? And what kind of actions, what levers are the best to work on to be able to reduce climate change? And
are there already some insights you can share, or is it basically still something you're trying to put into more context? This is all my colleagues working in the Earth Observation Directorate, so I'm not the centre of it, but it's as far as I understand, it's kind of being set up. And for example, this link to the data, we're setting up databases, we're creating user groups. So I can also, again, invite anybody who has any idea about data and how to use Earth observation data. I have the example, I think someone once created an app that helped farmers identify when moles were creating molehills in their land. So they could go directly and, here's a molehill. Okay, I can go directly and get rid of the mole. And it's very focused. And we are creating huge amounts of data at the European Space Agency, but we're not necessarily using it. And this is where we need to get everybody on board to come. And anybody has any kind of idea about apps for transportation, for Earth observation. There's something navigation. We're using now, boats use a certain navigation app to help them based on our data. It's to come and use it and really make the most about the data we're creating to improve people's lives. Yeah, I will definitely put the link in the show notes so that everyone who's interested or has a great idea can find Earth's digital twin. What challenges are you facing at the moment in your field of work? There's very recent challenges that everybody's facing in terms of price increase, obviously delays for getting materials, production times of elements. That's something we have to manage at a project management level. Funding, getting the funding we need for our projects, getting everybody to working together, that's standard business. Obviously, the current political climate, it makes our life a bit complicated in terms of working. We used to have the Russian launcher launching from French Guiana, which we can no longer do. We still work with Russia on the International Space Station, so that's one element where we still have international collaboration because we're keeping people alive up there. And the challenge, it's also part of the reason why I'm talking today. One of the big challenges I have is to integrate all of these elements, this future, this data future, this Internet of Things, the artificial intelligence. That's something a little bit outside of our normal field of experience. I said, I'm a propulsion engineer. I know how to set fire to things in a controlled way. But this, I can see it in the future. And we talked about all this. What does an intelligent engine look like? I don't actually know yet, but I need people to come and tell me and help me to look into this. And it's bringing on board all these new aspects of data, artificial intelligence, and integrating them correctly into our ongoing work. And again, we don't have necessarily the right kind of people at the moment who have experience in both, or at least have experience in one element that we can bring on board and talk to us. And so it's finding the best people, recruiting the best people, getting to work and getting the teams working together. And it's something I'm working on with our ESA human resources. We realize that we have a lot of challenges ahead. We need to be creating this data for climate observation, for navigation. We need to be able to handle it correctly. We need to be able to move forward. We know that ESA as an organization has to be, we're a scientific organization. We have to stay ahead of the times. We have to be moving forward, have an eye on the future and the way we need to be working in the future and the data we need to be using. And we need the best workforce, which means anybody who's good at something. And we have to be very careful to try and make sure that anybody who could be interested
is willing to apply, is aware of what we do and can apply and is going to come and work for us. It talks about diversity of workforce. We're a very diverse organization in terms of nationality. There's over 20 member states of the European Space Agency. It's not the same thing as the European Union. We have Switzerland as a member. We have Canada as an associate member. So we have lots of different nationalities, which is a great thing to work with. But again, it's diversity, obviously gender diversity, and then socioeconomic background diversity, all these things. We need the people who are very good, the best people in the world. You know, we don't care about the background. We need these people to come and apply for us. And we see that people generally from a more diverse background are not aware of what we're doing, or maybe aware of what we're doing, but are not going to apply because ESA went highway. And I keep making the point to people, it's up to us, it's up to ESA to decide if you're the right person for the job or not. So don't select yourself out by not applying. Apply, and then we will make a decision if you work. And we need a diverse workforce to face all these challenges of the future, all these challenges of integrating data and AI into space work. It's so that space can work for people, that we can provide all the answers, or help provide part of the solution to the challenges of the future.
We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by AFNet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or afnet-silica.com. That's avnet-silica.com. Excellent point. What skills would you be looking for? Asking for a friend.
But it was everything we talked about: data analysts, software engineers, anybody who knows something about artificial intelligence, people science, obviously science, and people I think don't understand how different jobs we have. So in space, it isn't just a scientist, it isn't just an engineer. And also, what's an engineer? Like, I'm an engineer, but I do project management because I like knowing about everything. I know about contracts, I know about finance, I know about all the technologies we're doing. We have quality engineers, thermal engineers, we have people working on cost. We have people doing amazing graphics and videos for us that really are necessary even for our scientists to understand what we're doing. And then that's just kind of the engineering side. And then everything. We need anybody with any interest in space who's good at their job, who works on the legal side. But yes, specifically on a kind of the topic of this podcast, it's people who have this kind of data background. It's something that's really, really going to be necessary for us in the future.
Interesting. We already now knee deep into the topic of diversity and how to let people know what it actually means working in a science or a STEM-oriented employer. As you say, it doesn't necessarily mean I have to be a rocket scientist. What made you choose that career path? You mentioned you like to set things on fire, which is...
Slight pyromaniac tendencies in our family definitely helped.
So that was okay.
I have a very cheesy kind of origin story about wanting to work into space. I was 10, 11 years old, and I was living in Sheffield at the time, and I went to stay overnight at a friend's house, and she had what we call French windows, which are kind of large door windows from her sitting room out to the garden. And we were having a sleepover, everybody in their sleeping bags in her sitting room. And it's Sheffield, it's cold in the north of England, and it was one of these kind of cold winter nights, no clouds whatsoever. And I got in my sleeping bag and I laid down on the ground, I rolled over onto my back and I looked out the windows and I had the most amazing view of, I think it must have been the Milky Way. I just saw the night sky, all the stars, the galaxies, I think. I didn't know what they were, but it was just absolutely beautiful. And that was it. I decided I want to work in space. That's it. That's what I want to do with my life. So I went home the next day and told my parents, I want to work in space. And they're like, yeah, okay, fine. Go for it. And we took it from there.
So basically the advice you could give to young listeners who might still be looking for a career path or wondering if they could make a career in space, just look at the stars and dream big.
Dream big. I gave a talk recently to my old university, to a women's group there, and I gave them the kind of 4 life lessons I've learned from this far in my career. And the first one is, you are enough. Nobody in my family was a rocket scientist. I don't know any rocket scientists. We're not engineers. My parents are not engineers. You're enough. If you're driven, if you work hard, if you're driven, you can make it, and you don't need connections. You can make it. Dream big, exactly. Have a dream and go for it. I wanted I wanted originally to be an astronaut. I'm not an astronaut today, but I've had an amazing career. I've had an amazing life. I've lived in French Guiana. I've done rocket launches. Now I live in Paris working on future technologies. So even if you don't achieve your dream, the journey is going to be worth it when you get there. There are going to be problems on the way. It's not going to be easy. Life is not fair. Things are going to happen that you're not going to be, not going to be nice, and you're going to have to work with it. And what I said was to, if you're not winning, if you can't win, then change the rules of the game. There's sometimes you kind of get so involved in something. In fact, it's not right for you. So it's okay to say, okay, this actually, it's not right for me. I can change. I'm going to move and then still achieve what I want to achieve, but in a different way. And at the end, it's also clearly very cheesy, but just be yourself. I said I had this example. I once went to a meeting. I was a little bit late because I was in a previous meeting. I kind of walked into this room. There was 50 men in dark grey suits kind of turned around to look at me, and I was in a kind of bright green fake Chanel jacket that my mum had made for me. And I just realized at that point that I can't fit in. I'm never going to fit in. So there's no point in me trying. I just have to be me, and that my experience, that my qualities, my work is enough. I'm good at my job. That's the first point. And the fact that I'm slightly different, that I'm a woman with 50 men, I bring a different viewpoint. And it's the same thing. Everybody, your work is great. And then the diversity is really important in what we're doing. And if we're doing large projects with multiple people, we need multiple, again, we talk about multiple nationalities. We have multiple people. We need multiple different work experiences, and we need different ways of solving problems. And this is why we need a diverse workforce, because we need all these different ideas working together to solve these big problems that we have.
Yeah, this is such an important message. And I've had a discussion with a fellow engineer on this podcast, and basically her takeaway was she was very passionate about her line of work, but she was a little bit older than us, I think, or started out at a different decade, so to say. And she gave up because she just... It's hard to be yourself when you're constantly,
you're other. You're always it's getting better today, but there's lots of times I've been the youngest person in the room, the only British person in the room, the only woman in the room, and you kind of notice it. You're like, okay, here we go again. Okay, you've noticed it, and then you just get on with your job. But it can be tiring to constantly have that. Not quite have the same when you're going out for dinner. You don't quite have the same centers of interest as other people, or managing. Okay, I'm a mother of 2 children, so managing motherhood as well as working. But first of all, my husband, really, we are co-parents. We're both having the same issues, so we're working together. Honestly, kind of lockdown COVID helped because everybody was doing WebEx meetings from home, and everybody had kids interrupting them. So everybody has a family life. Everybody has this stuff to manage. Working from home now also makes life a lot easier. I can really manage my workload and my personal life at the same time. There are improvements that have come through that now make it, I think, maybe a bit more slightly easier to work, to manage and also, within the organization, I have the confidence placed in me that I'm able to manage my work as I see necessary. Yeah, like you say, it's tiring, but it's getting better. And I think there is a little bit of a change coming as people realize, again, I work with USO Human Resources. It's very clear from our side, we need as diverse workforce as possible. And they are doing everything they can to make that happen.
And as you say, it's not only about getting girls and young women excited into STEM studies, but also, of course, a more diverse perspective, different social backgrounds, different cultural backgrounds, etc. But then I think it's also not only a challenge to getting them interested, but then also keeping them on, and it'll get better. Stay with us. And how do you retain talent? Do you have an idea?
I don't have the answer for that, and I don't think our home resources have the answer for that yet. Again, it's a big question. Like you say, you can hire people on, but if you can't sell them a dream, and then not implement it, then you're going to lose them. So you can hire someone, but if they leave within a year or two because they're not happy, then that wasn't worth it. So, like you've pointed out, it's hiring people, and then it's also managing career and expectations. I think within ISA, we have a certain advantage in terms of there are so many different projects that we're doing, so many different places to work, different projects to work on, different things to do, that there's a natural diversity of work. So you can move around relatively easily, and you say, okay, fine, I want to try something else out. You can have quite an interesting career while staying within ISA. This is an issue for us because we are hiring more and more younger people. Before, it's been quite an organization, quite older, more experienced people. We're hiring people in, so we have to start managing their careers, keeping people interested, moving them around, giving them responsibilities, and making sure, again, that we have this quality of life, that you have a balance between your personal life and your professional life, which I feel I'm very lucky with, honestly, that I work hard, but I managed to have a balance so that I can also feel like I'm doing okay in my personal life as well.
This is a personal question. How old are your kids? I'm just asking because I would like to know if they have already a career interest they mentioned, or are they too small for that?
They're far too small. They're 3.5 and 18 months, but their rooms are full of rockets. Like the poor things, everything in their life has rockets and stars in it. I've got it next to me. The car seat of my daughter has got stars and comets on it. So they will know that space is a possibility. Obviously, they will do whatever they want, but that's also, I'm quite happy with it. Again, I would like every school child in the world to know that space is a possibility. You can work in space. Again, doing a variety of different tasks, but space is a possibility for everyone. And it's a really interesting career. I said I've really enjoyed my career. I've traveled around a lot. I've had experiences that I think that I would never have been able to do otherwise. It's hard work. There are stressful points as well. But it's been a really great career, and I want everybody to know that it's a possibility for them. They can also be a baker if they want, but space is an option.
Can be a baker in space. You need to eat on the moon, I guess.
You need to, yes, yeah. It's how I'm just thinking about how would an oven work in space? So we've made a coffee machine, espresso machine has gone up into space, but that really was, again, you have to rethink everything. So baking in space, it could be the next frontier.
I think about that. As many people during lockdown, I discovered baking for myself. So anyway, do you think you will go to space?
No, I think no, as I said, I originally wanted to be an astronaut. And in fact, I'm very happy with where I've ended up. And I know about the rockets that they're going on. I know I'm the one that, does almost the taxi driver, the truck driver. I take the people there, but I'm not the passengers.
Okay. Do you think your kids will go to space?
I really love the idea of them kind of going on holiday in space or something in 20, 30 years time. I would really, going to the moon for a holiday. I do believe in, obviously what I'm doing in space, it's a really interesting job, but I really believe it as part of humanity there's exploration. Again, I said, I'm a project manager because I love knowing everything. I'm working in space because it's so many interesting questions that we can answer from space, and also so many interesting questions that come out from what we're doing. There's this exploration aspect, there's this curiosity aspect. For me, it's the future of kind of humanity is going into space. It's the space economy is already a very important part of everyday life. And I think, again, people don't realize your mobile phone, the weather, Google Maps, all of this comes from data from space. The bus system, when it's 2 minutes away, it's because data from space is telling you it's 2 minutes away. It's an integral part of everyday life, and it's just become more and more important. And we're going to, starting thinking about production in space. You can make very, very pure fiber optic cables in space because of the microgravity aspect. On Earth, we always have gravity that's pulling slightly heavier particles to the bottom, so you always have an slight impurity layer. We don't have that in space. We can make very pure crystals. Is that at the moment it's so expensive, it's not worth, but at some point, if we reduce the cost of access to space, which we're trying to do, make sure launchers getting into space is cheap, then space can become part of the world economy. Then we start going into space. There's lots of people now talking about tourism in space, but at the moment it's just a flight, kind of go up, come down again. If it's very expensive, you can spend a few days on the space station. I would like it to be democratized, and people can, more and more people can enjoy space in the future, not just the preserve of the rich.
Yeah, sure. Before I come to my closing questions, is there anything I have not asked you, anything I have missed you would like to talk about?
Space music.
Space music? Yeah, we already talked about a possible playlist.
I actually wrote one down. I've got my playlist.
Oh, did you? Please share it with us. Then we can link it as well in the show notes, and so people can listen to...
Yeah, some of the best space. I have to start with, it's also because it's a friend's 40th birthday tomorrow, and when we were younger, we loved it. It was Jamiroquai and Cosmic Girl. Mm-hmm. That was one of my favorite kind of space-related, and it was me and her. We were Cosmic Girls, and that linked to my money. I was going to go into space, so...
cool.
It was for us. And then I made that we talked about it earlier, I made the joke we're creating new engines, we're testing technology. So we do what we call hot fire tests. We put an engine on a test bench, and I started creating a playlist for that. And one of it was the Prodigy and Firestarter. So again, going back to this, Pyromaniac, there's a fun part of my job, and having hot fire tests of engines is part of it. And I have that, I'm a Firestarter in my mind. There's another Prodigy one, which is outer space. I'm going to outer space to find another. Yeah. So again, curiosity, exploration. Is there life out there? We're going to keep, we keep looking for it. David Bowie and Space Oddity, obviously. And as I mentioned, my son is called Tom, Major Tom. So, there's a bit of a space geek link for him, obviously. And I don't know if you know, but there's a band called Public Service Broadcasting, and they did a whole album on the race for space. Mm-hmm. And they took original recordings from like the Sputnik, reactions to Sputnik from Apollo launches and things like this. And they've created an absolutely amazing kind of immersive album. So anybody who's interested in space should listen to that. And then the final one is something I discovered recently. It's a band called Hen Ogledd. I think they're Welsh. And they have a song called Space Golf. And actually, one of the lyrics is you can't play golf in space. And in fact, you can. People have played golf in space. They've had people take knocks of golf balls off the International Space Station. But the song is really good anyway.
You should get in touch with them. They would be like, oh my God, the European Space Agency is listening. They told us our song is wrong. Is that your playlist?
Yeah, that's it.
That's great. So that's actually a very cool idea for a question I could ask every guest. What would be the playlist to your career?
Yes, yeah.
I will do that from now on. That is very cool because I have been looking for a signature question. Usually I ask something like, what is the common myth about rocket science? What would be a common myth about rocket science?
Like I said, it's that it's kind of brainy old men, white-haired old men. It's not. It's everybody can be a rocket scientist. Everybody's a rocket scientist. I used to do launch operations. So in our European Space Agency rockets, they launch from French Guiana, which is a part of France in South America. Mm-hmm. There's various reasons why we launch from that, but the launch team, operations team, was a really young. It's 30-year-olds having this amazing, stressful, important job and doing it really well. You can be a linguist and work in space. European Space Agency, everybody talks multiple languages. You can be creative and work in space. My job is creative because there's things that don't exist yet. We're imagining what the future could be. So we're having to create new things, create new systems. It's very social. It's teamwork. It's talking to, I talk to legal people. I talk to financial people. I talk to teams all over Europe. So it's not dry at all. It's really, really interesting job, and anybody can do it if they really want to.
Are you present when the rockets go up?
I have been in my previous job. So in my previous job, I was physically assembling the rocket. I was there doing the final countdown. Now I tend to do a bit more of a kind of PR role because I know about rockets. They'll send me to an ESA base. They'll send me to, I'll be there talking through the launch, but I won't actually be physically on site. When
is the next launch? Do you know?
It's going to be vague. It should be a Vega in September. So these smaller, we have an Ariane 5 we've just finished using. We're developing Ariane 6 now, which will launch hopefully end of this year. And the next one we have is Vega, and it's going to be September or October. We have it's a bit of a slow year for European rockets, but we're working very hard to get everything back on track.
So you'll be launching from Guyana. So is there any chance I can see something from Europe?
I mean, everything is always streamed. There's ESA TV when it's an ESA mission. So there was one in April that was a JUICE launch, and that was streamed. So we had an event in our control center in Germany, and that's where I was doing the talking. And that's streamed live on ESA TV. It's always streamed by Ariane Group, who is the company that actually does the launches. There's also quite often press events. Again, when it's an ESA mission, there'll be a press event, and you can apply to be part of the press event and to assist either on site or online to the retransmission of the launch. So again, keep track of kind of ESA announcements, call for press and stuff.
I definitely will. I will take a look and put the link again in the show notes. Thank you so much, Kate. This was brilliant. I will now let you get back to your vacation. Well deserved, I guess. And hope you have a nice summer.
Thank you so much for having me. You may have noticed I love talking about space, so I'm happy to do it.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.